Alright boys, so here's a little update. I've been busy with the Dinah robot project. Um, like I said, that's a project that's following along with the Hope Light project by the Robot Studio on YouTube. I'm totally overhauling his design, but I'm still keeping some of his design philosophy and some design elements. And I'm also trying to keep up with the pace that he's going with this open source robot. So I'm just going to whip something out that's much beneath the quality level that I normally am aiming for, but will at least get me something to show for my work as a change. So I consider this like a side project that's like a side quest and something that basically is a practice run to kind of get me out of R&D hell, so to speak, where I'm just building, and then scrapping and having to try something new, trial and error. Just never-ending process of not being able to get anything moving because I keep changing the designs and stuff. So this is going to be just a lot more simple. Um, okay, so you see I've got the Eve base mesh here, and I'm just going to use the same base mesh for Dinah as Eve, so they're the same. All I have to do is change the face a little bit, maybe tweak a couple little details, but basically keeping the same body for the most part. I don't see any reason to change it significantly. Um, and then here, I matched up inside this model the skeleton, which I copied from the Able skeleton, and then I went ahead and modeled to match the skeleton, the steel endoskeleton from the male sex doll that I robbed from that doll for this project. Um, and so now I'll show you guys. This is the endoskeleton. You can see how it's built. I changed this hinge system from the original endoskeleton and added it because a different sex doll endoskeleton had this improvement with a double joint here. So this will rotate into this, which just creates a little more separation from the thigh and the extended leg when it bends. It'll be more out here rather than like a perfect angle right off the top one where you can't fit motors in here. This just gives a little more separation for more motors to fit. So little stuff like that I improved by copying this other one. I also added a bunch more degrees of freedom here. This will go up, down. This one will rotate on this axis to come this way and this way, forward, back. Then this one will rotate, and then this one is a double jointed, so it's just more capable. It could come up, and then this one could rotate freely separate from this going up and down. And then this will be like the shrug, but then this could be like smaller adjustments. So, and then for here, this will be forward, back, and then this one will be left, right, and then this one will be forward, back again for the head. So this is kind of my final design for the endoskeleton, at least tentatively, and it's exact match for this skeleton, which you'll see here. It lines up with the joint being right where the humerus meets with the clavicle and scapula, which is called the shoulder girdle. It lines up perfectly with that. And then it lines up perfectly with the elbow joint here, and it lines up perfectly with the hand. Also, you'll note, you see how this is all attached together? I grouped them. I'm actually going to be using the ulnar radius, which I fused into a single bone here. I'm going to be using that as the basis for this wrist, because I want this whole hand to be able to rotate back and forth, bend forward, backwards, left, right, and rotate on the normal structure that these bones normally rub against. So it's a really excellent and special design, the way these bones interact with these bones to give the human hand's actuation. So in order to bring the human-like bone structure of the hand, merging it into the steel, I'm making all these solid ABS 3D prints, and I'm going to have to just mount this double bone merged into one onto this metal shaft. I decided to go with the human-like bones for the hands and wrists in order to gain the full 27 degrees of freedom that a human hand has, And a lot of robot hands are only at like 17 degrees of freedom or whatever, or 22, but barely any of them get the full 27. I want full dexterity, full degrees of freedom, and to design that mechanically gets really complicated. So it's a lot easier just to use the human design for that. So I just went with just a stock human design. So I'm 3D printing all this in ABS, and then I'll be able to join that to the steel endoskeleton from the sextile that will be heavily modified. So I've got this little 3D ruler here. It's 15 centimeters long, and I'll be able to measure these joints as well as all the little modifications I made to this thing, and modify the real life steel endoskeleton that I robbed from that sextile. I'll be able to modify it to match these proportions, which will then match the proportions of the Dinah robot's exterior shell, so that everything will sync together perfectly. And then for this exterior shell, I may end up 3D printing it in one way or another, and then building my silicone off that 3D print somehow. I'm kind of leaning toward that route, so we'll see on that. But that's way down the line. I don't feel the need to build basically an exoskeleton nor the silicone stage until I get the whole thing actuated, or at least do the arm. Then I can maybe silicone the whole arm in. But I'm kind of leaning toward going with my original approach of once you build an arm and working head, you have that arm build the rest of its entire own body. So I may just go that route, even with this project. So I'll pretty much get the arm fully actuated and then have it take over, and I'll just focus on AI from there. So that's my update, and then I can show you guys real quick. Here is the full 3D print in Cura, which is my slicing software, of that hand we were just talking about. So that's how it will come up. And that's actually printing right now in the other room, and it's about 90% done. A couple bones messed up in that print. This one seems messed up, and maybe, I think like this one was messed up. Or no, actually, I think this one was messed up. So, but it makes sense why it was messed up. I didn't lay it on the bed very well. Too many supports, more room to fail. So I have to reprint like 2 bones out of all this, but most of them are looking good. So that's a 15-hour print. It's been going for a while. It's been going overnight and then some. But yeah, once I get these done, I'll be able to wrap them all in spandex and sew them all together, and then mount that to the steel endoskeleton. So that's where we're at.